Hello my dear children, welcome back to the lecture series of aldehyde, ketones and carboxylic acid of Maharashtra Board Grade 12 Chemistry. In the previous video we started with the preparation of aldehydes and ketones. Today we will continue with the same thing. My name is 𝐒𝐿𝐵𝗲𝗏 and you are watching 𝐿𝐵𝗲 classes. Let's get started. So today we are going to start with the preparation number 4, that is from ester. You all know the functional group of ester is C double bond O, OR 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 dash you can write. This is the functional group of ester. So here you can see we have taken an ester RCOOR dash. We are treating this ester with dibyl H. Dibyl H is what? It is a very specific reducing agent. Diisobutyl aluminium hydride. Okay. So dibyl H we have taken. This is also can be written as dibyl H. Okay, at 195 Kelvin temperature. What you do is break this bond. This is, if you break this bond, this becomes plus and this becomes minus. One of the hydrogen you give it to this carbon atom and the other hydrogen you give it to this oxygen atom. It is just to make you understand how it is coming. So RC double bond O, one of the hydrogen is given to this carbon and the other compound is R dashed O, another hydrogen is given to this oxygen. So these are the products of this reaction. So what are the products you see? This is my aldehyde and R dashed OH is alcohol. So the overall reaction is when the ester is treated with dibyl H at 195 Kelvin temperature, we are getting aldehyde and alcohol. Let's take a particular example. This is methyl ethanoate. This ester is known as or named as methyl ethanoate. This is treated with dibyl H at 195 Kelvin temperature. Break this bond. One hydrogen you give it to this carbon and another hydrogen you give it to this oxygen. So we get CH3 C double bond OH plus CH3OH. This compound is called as acetaldehyde and this is called as methyl alcohol. So in this reaction we are getting both aldehyde and alcohol. So with the reaction 4 we completed with the preparation of aliphatic aldehyde and ketone. Now from reaction 5 we are going to start with the preparation of aromatic aldehyde and ketone. The first reaction for the aromatic aldehyde and ketone is the Itard reaction. It's a name reaction. So we are starting with toluene. If you see, this is nothing but toluene. We have just written methyl group like openly like this. This is my methyl group, which is written here as C and then the 3 hydrogens are like this, because here I want to show you what is it happening actually, what is the complex form, so it is written like that. So the substrate is here toluene and that is treated with CrO2Cl2 in presence of carbon disulfide is a solvent over here. What happens is this hydrogen you attach with this oxygen, one of the oxygen, this hydrogen is also attached with one of the oxygen. See how the complex is formed. There will be a complex form which is little difficult to remember, but the way I am telling you, if you remember like this, it is easy. Okay. So see, nothing is happening with this carbon and this hydrogen. So I will be writing the carbon and hydrogen like this only. And now this bond and this bond. What is happening? Just add one carbon to this, one oxygen to this carbon. Okay. Among these 2 oxygen, I am adding one oxygen to this carbon. And then I am writing Cr. And then another oxygen and hydrogen you attach together, so that is OH and Cl2 is there. Same thing you do here, one of the oxygen from the 2 oxygen, one of the oxygen we are attaching to carbon and then we are writing Cr and then the other oxygen and the hydrogen from here, they are written as OH and Cl2 is there. This is the complex form. This is little difficult to remember, so I told you this way if you remember then it will be easy for you. Okay. Now after this you are going to hydrolyze it. When you are hydrolyzing it, just break this bond and break this bond. 2 bonds are broken. So and with this oxygen attached one of the hydrogen and with this oxygen attached one of the hydrogen. How do I show you? I am showing you like this. Okay. So what is happening? Two bonds are broken. Now remaining is oxygen. That oxygen will be attached to the carbon. So see what is happening. This is carbon. This oxygen is attached to the carbon and this hydrogen is already there. So we are getting benzaldehyde and the side product is Cr. Now this oxygen is getting attached with one of the hydrogen. So OH is already there. Another OH will be giving you OH whole twice Cl2, and the same thing will happen here also, CrOH whole twice Cl2. So we are getting two molecules of this compound. Okay. So what is the main product is benzaldehyde. Benzaldehyde. This is called as Itard reaction. Sometimes this complex, writing this complex is difficult, so directly the reaction can be written like this. This is my substrate toluene. Okay, this is treated with CrO2, Cl2, CS2, CrO2, Cl2, CS2, followed by hydrolysis. Okay, can give you benzaldehyde. The product is benzaldehyde. So you can write down both the steps together and write the reaction like this. But then you might lose marks. So that is why writing this complex is important. And I told you how to remember to write this complex. If you remember it this way, it will be easy for you. The next reaction for the preparation of aromatic aldehyde is from toluene again. Our substrate is again toluene. And now we are treating this with acetic anhydride. Acetic anhydride. So basically this is anhydride and we are giving CrO3, which is an oxidizing agent. This is an oxidizing agent. So again toluene will be oxidized to benzaldehyde. See how? Break this bond and break this bond. Give one of the hydrogen to this carbon and another hydrogen to this carbon. And this oxygen to this carbon, because we are breaking these two bonds. So instead of these two hydrogens, one oxygen will be coming here. So what is our product again? We are getting benzaldehyde. If you see very closely, we are getting benzaldehyde again. And the byproduct is CH3CHO. We are getting two molecules of CH3CHO, that is acetaldehyde. So in this case, we are getting aromatic aldehyde as well as we are getting aliphatic aldehyde. Acetaldehyde is an aliphatic aldehyde. So we are getting aromatic aldehyde as well as we are getting aliphatic aldehyde. So the substrate is toluene again. We are treating that with acetic anhydride in presence of CrO3. Toluene will be oxidized to benzaldehyde. So this break these two bonds and 1 hydrogen you give to 1 carbon. Pending is what or remaining is what? Only oxygen that you attach to the carbon over here. This is how you need to remember this reaction. The next preparation is by the side chain chlorination, which is a commercial method. Again our substrate is toluene which is treated with chlorine. One of the hydrogen from here will be substituted by chlorine. So suppose this hydrogen from here is getting substituted by chlorine, one chlorine and another chlorine, and this hydrogen will be liberating as HCl. So we are getting benzyl chloride. This is called as benzyl chloride. This compound looks like this. Benzene ring and then CH2Cl. This is called as benzyl chloride. Again you are treating benzyl chloride with chlorine. So again what is happening? Another hydrogen will be substituted by chlorine. So this substituted hydrogen and another chlorine atom will be again liberating as HCl and will be getting benzyl chloride. This is called as benzyl chloride. This looks like this, CHCl2. This is benzyl chloride, and now this will be treated with two molecules of water. And these two molecules of water, now what happens is two OH is obtained from here. This two OH will be substituting the two chlorine. So this chlorine is substituted by OH and this chlorine is also substituted by chlorine. So the two chlorine which are liberating will be reacting with 2H and again two molecules of HCl will be liberating from here. We are getting a complex like this which is very unstable, because when both the OH group is attached to the same carbon atom, then the compound is very unstable. So what happens is from here water molecule comes out. Water molecule comes out like this. So this is the water molecule which will be coming out. So finally what you are getting, see, you are getting benzaldehyde, CHO. So you are getting benzaldehyde as the product. So this is the way we can prepare benzaldehyde by the side chain chlorination of toluene. Now the last two reactions, the second last reaction is known as Gattelmann-Koch formylation reaction. Formylation means formyl group addition, and formyl group is nothing but CHO group. CHO group, that is aldehyde group, is also called as formyl group. So this is formylation, that is formyl group addition. What is happening? Benzene is treated with carbon monoxide in presence of HCl, and the reaction happens in presence of anhydrous LCl3. You get benzaldehyde and HCl gas. How it is happening? I am just showing you this way. First of all, this CO and HCl will be reacting together. CO plus HCl will give you HCOCl. It will be giving you HCOCl. Okay, now this HCOCl will be reacting with benzene. This is my benzene plus HCOCl in presence of anhydrous LCl3. You know what is the role of anhydrous LCl3? It's a Lewis acid, so it will be abstracting this chlorine along with this 2 electron. So this will be plus. So there will be the electrophile generated this way, and then this electrophile will get attached to the benzene ring, and you are going to get CHO group attached to the benzene ring like this. Okay, so this is the overall reaction. This is how it is happening. You can show it in one step. This is called as Gattelmann-Koch formylation reaction. And the last reaction is Friedel-Crafts acylation reaction, where benzene is treated with, this is my benzene, which is treated with acetyl chloride in presence of anhydrous LCl3. Again the same thing will happen here. The electrophile is COCH3, C plus, okay, COCH3. So that will get attached over here, and will be getting acetophenone as the product. Okay, so in both the reactions, you know that anhydrous LCl3 is very important, because that will give rise to the generation of the electrophile. So here we have completed thoroughly with the preparation of aldehydes and ketones, both aliphatic aldehydes and ketones and aromatic aldehydes and ketones. Now in the next video, I'll be coming up with the physical properties and the chemical properties. Thank you so much. If you feel these videos are important to you, please subscribe the channel and press the like button. Thank you. Stay tuned.